punishing us now?
Sir, I'm
Okay, if there's no water, bring yogurt for us.
I'm not in the catering.
Amana ai kamar yayi angon da mu da wata tsakiya. Ta tsakiya?
Yes. The two of them that PhD. So judges, if you see, there are two candidates that put PhD in front of their name. Those are the doctors. So that when we judge them is different from others. Yes. Same thing for most people to look at
I think like this, it points out both the.
Alright.
This was one of the
Can you
objects.
call up the first like this?
BHR 360. Because yesterday I was here.
So
When the
please,
judge are asking
for the
questions,
purpose
I
of
will get you. Then get this one.
fairness, there's now water.
No?
If you know, you need to clear your voice. Water can reduce pressure and tension. Don't underestimate this water we are. Don't come and join us. You sure? You can't do too much.
When I purposely make camera, they should.
This one. Oh yeah, are you ready? Friday. Are you ready?
I did it Friday.
Yes. Guys, let's go for you Friday on the road. Just take the.
As soon as we pass our answer,
Go back to your. All right, your time starts now.
Good day, judges. Good day, moderator. Good day, fellow students. My name is Ayodele Friday, speaking to the Central Engineering System at Federal University of Petroleum Resources. And the title of my paper is Revolutionizing Recoverable Food Analysis. That is unlocking the power of AI-driven optimization for accurate PVT prediction. First of all, I would like to explain what this topic is all about. Simply means making a great. This PVT analysis is so important that we're able to determine our fluid properties, such as the viscosity, oil formation volume factor, gas oil ratio, and so many more. Without these properties, we will not be able to make the right decision about our well. But with these properties, we will be able to make the right decision about our well. And this is, as I said, is usually done in the laboratory. But aside laboratory, another alternative way is through the use of the empirical, because they are derived based on region. For example, studies who derive the empirical formula using the California food. If we bring the formula to apply it to our food here in Nigeria, it will definitely yield significant error, which are dangerous to the industry. which can lead to wrong decision making about our oil and gas. And my aim is to optimize, that is, my aim is to reduce this significant error by optimization of PVT correlation using the optimization algorithms. Yes, coming to the literature review of this study, there are many authors who have actually did the same work on this. We can see Spanish, who made use of California fruit, dated in 1947, Glassos dated in 1980, McCain dated in 1991, Regional Studies dated in 1997 to 2009, Dindrop and Pittman dated in 2004, so on. Time will not permit me to list all of them. But still, the issue of this significant error still remains the same, even today. Yes, as I've said earlier, my aim is to reduce this significant error, so that if you bring the formula, the empirical formula to apply to our own crude, it will not yield any error. Coming to the methodology, I did the data gathering and preparation, I did the data control and quality assurance, I uploaded this data into MATLAB. MATLAB software is used to program this algorithm, that is, it's used to implement these algorithms. I estimated the PVT data from the existing correlation. For these studies, I considered 3 existing correlations: the Amaru, the Pespersky Fashad, and the Spanish. I did the PVT data I considered. The PVT data is oil formation volume factors. I calculated the oil formation volume factor using the existing data, which are the Amaru, the Pespersky Fashad, and the Spanish. I compared the results with the one I got from the laboratories. There were wide margins between the 2 results, which is the one I did from the empirical derived formula was quite different from the one I got in the laboratory, and the laboratory is 100% correct. Okay, and we can see that it shows a need for optimization. Yes, I did the codings. I implemented optimization algorithms. Yes, I said algorithm because I consider 2 different algorithms to ensure the efficiency and the accuracy of my work. Then I compared the results statistically. For the first algorithm, which is the gradient descent optimization algorithm, we can see for studies, we can see the experimental line with the blue line, we can see the calculated line with the black line, and we can see the optimized line with the green line. After I optimized this Spanish correlation, the optimized value moved closer to the experimental result, that is the one gotten from the laboratory. But with this can clearly show for the Amaru here, we can see the experimental line with the black line and the calculated line with the pink line and the optimized line with the blue line. We can see that the calculated line was very far from the experimental results. But after my optimization, after I optimized this formula, it moved closer to the experimental results. And the same thing applicable to the Pespersky and Fashad result. Okay, coming to the error analysis. Yes, all of this, they both increase, but I will not permit me to go through all of them. We can see the average percentage error for Pespersky and Fashad reduced from 1.3823 to 1.19. For studies reduced from 1.28 to 1.16. And for Amaru, reduced from 19.5 to 4.99. You can see the white. Focusing on one of the major one aspect, which is the one at the last here, that is correlation coefficients. That is our R squared. As we all know that the more our R squared tends to 1, the better the accuracy of our work is. Yes, it improved from 0.78 to 0.79. The second one, which is the standing improved, that is improved from 0.788 to 0.789. And the same thing applicable to the Amaru. Okay? Coming to the second algorithm, that is to ensure accuracy, to ensure accuracy, optimization efficiency, and then model reliability. I consider the second algorithm, which is the TNDO optimization algorithm. That is teaching learning based optimization algorithms. Yes, you can see the graph here for the calculated one with the dark line. We can see that after I optimize this, it moves closer, that is almost perfect, equating to the result gotten from the experimental. And you can see for this second one, which is the Pespersky and Fashad as well. We can see the calculated with the dark line, we can see the experimental with the dark line, the calculated with the pink line, and the optimized with the green line. The optimized is almost or approximately equating to the 140 in the with the experiments. And the same thing applicable for the last one there. Yes, coming to the error analysis, we can see coming to the one at the down here, the last one, we can see the average relative error reduced from 1.44 to 0.2 for standards. We can see AMAU reduced from 0.7 to 0.12. And we can see for Petrovsky and Pasha reduced from 0.9 to 0.06, which shows the work is actually nice. And we can see for the coefficient of fitness, that is our R squared, it increases from 0.77 to 0.99, approximately equating to 1. And we can see for AMAU from 0.9 to 0.99, and we can see for Petrovsky and Pasha from 0.90 to 0.99, which I figured out there, approximately equating to 1. That is, which shows the accuracy of our work. Then, to my conclusion, one of the unoptimized correlations out of the three, that is Klein's, AMAU, and Petrovsky and Pasha, was able to predict the oil formation volume factor correctly. None of them. But upon that is after I implement my optimization algorithm, that is after I optimize it, we can see for gradient descent algorithm, we can see it asks our R square to be 0.79, and you can see when I went further to reinforce my claim, that is to strengthen my claim using the second algorithm, which has a coefficient of 0.99, that is for the VLBO optimization algorithm. We can see that this work is actually a good work done. Okay, to my recommendation, I recommended that in any area, any field we have empirical correlation, they should be optimized before being used, so as to reduce any form of significant error. And this is not only applicable to oil formation volume factor, as well to the other properties of our food, such as the gas oil ratio, the viscosity, and the density as well. And not only applicable to petroleum engineering, to all other fields of engineering, anywhere we have empirical correlation, they should be optimized so as to reduce the significant error. Thank you.
How are you doing? Well done. Good job. Good job. You say we should optimize any of our correlation. Do you optimize what is already a fact?
So as to reduce
what you are trying to say is that only optimize when you have correlation and have margins of error.
Yes.
That is what you are trying to say.
Yes, sir.
Thank you. George, please.
Very nice work. The data used for this work, are they mental data?
Sir?
The data you use for this work?
Yes, sir.
Was it Niger data, or what type of data you use? What did you get the data from?
Your PDT.
Your PDT data.
Where I got them from?
Yes. Your
You
source.
said you did get data gathered with processing, yeah?
Yes, sir.
Yeah, so the data you use, which type of data, where did you get it from? Is it Niger data or what?
Yes, sir.
Okay. So okay. This is a yes, sir. I hope you understand what you are saying. Right? So why are you using just I think I saw standing correlation, Halmaun and Petrovsky and Pasha, right? So why is it just 3 empirical correlations, right? To compare your optimized algorithm. That's number 1. So why are you comparing an empirical correlation that is developed in another region?
Yes, sir.
Remember you said the empirical correlation different from region to region. But now you're now using a data that is obtained from the Niger data to compare an equation that was developed without using the Niger data equation. I mean, I think I know like the empirical correlation that is developed by some Nigerians using the Niger data, like KCP Mama, right? Even the Share one too. So I can mention 3 or 4 of them for you, right? So I mean, using just 3 of these equations that are outside the Niger data region. So like you said, it's going to cause problem in the oil industry. So you are also causing problem in the industry. You are having problem.
No. Thank you, sir.
Okay.
Yes, I said I'll consider 3. That is the Petrovsky, Pasha, AMAU, and
Equations also for the Niger Delta. You understand? You compare it also with the Standing, the Al-Mahmoud, and the Petroski. Also with what you are doing. So you have had probably 5 different empirical derived correlations to compare what you are coming up with. I mean, you said they differ from region to region, but you are not giving us, you are not comparing your work with the one that you were done from the Niger Delta.
Thank you very much, sir. Even the one derived from Niger Delta, if they are to carry it outside any region to apply, they should always optimize them as well. Because
that when you are getting correlation from Niger Delta, the error you'll be dealing with will be smaller, and that will make your work to even more efficient. That's just what we are trying to say. All right, so just note it and look at it. Yeah. Any other question?
Based on the other basis of this whole work and quality, cannot depend what was like a kind of quality and because the one thing that validation of the model yes, yes. What is the first one? Also have slide number, very important number and slides, so that you can okay? So this is going to give me significant error. What are the examples?
yes, as I'm saying it now, that you don't be able to know how much of oil is out in the reservoir. You don't be able to know the amount of oil is out. And
So you will know. Because you've already done the PVT now. You know what you tell us that you all right, thank you. I think we spent enough time on this. Thank you. Thank you very much. Good job. Please give me a round of applause. Well done. So can you just try moving it just to be sure? Good. Okay. All right. All right.
Communities. However, today, the reverse is completely the case. This is as a result of the Nigerian gas policy through its domestic LPG penetration program. This program is targeted at improving or increasing the level of adoption of LPG, which are there to safeguard the operations of LPG plants. But the next important question is, how safe are we? With what degree of certainty can we say that this standard are there to actually safeguard us and are actually working? With that in mind, a literature review was conducted and a significant gap was outlined, whereby no prior research was found which assessed the safety integrity level of LPG plants in the country. As a result, this paper aims to assess the safety integrity level of LPG plants in Nigeria by scrutinizing the regulatory standard to assess the level of safeguard they provide to the community. Here is the methodology adopted. It started from proposing sampling to choose an LPG plant that is actually that follows the regulatory standard very strictly. Then data was collected, safety integrity level was determined using layer protection analysis, consequence modeling was conducted, and mitigation measures were proposed. Alien location of hazardous atmosphere software was used for consequence modeling. And the one here is a testimony of the consequence model. The result, since a layer of protection analysis was chosen for safety integrity level assessment, there is need to establish a hazard consequence there. As such, hazard identification was conducted, and the identified hazard were given risk factors based on severity and likelihood. Major hazard analysis technique was used for hazard identification. This is because major hazard analysis will narrow down the hazard to only those capable of causing loss of containment. As such, 4 major hazards were identified: major and minor leakages, tank over pressure, and incorrect or inaction by an employee, each of which can cause fire, explosion, or hazardous release. After hazard identification, in order to establish credible incident scenarios, incident history was used and two important scenarios were come up with. That is car or truck ignition during discharge or delivery, leading to fire and ultimately leading to tank explosion or deliver release. The safety regulatory standard collected from the NMDPRA were used to establish the existing safety layers present and their probability of failure on demand were identified. These were presented in the figures. Yeah. For the first model, which involves the tank explosion, after their protection analysis, a residual risk of 1.776 exponent minus 6 event per year was identified. This is quite insignificant, meaning that it might actually safe with regards to tank explosion. However, if we consider the cumulative societal risk with about 2,000 LPG plants in the country, now the cumulative risk aggravated to 3.552 exponent negative 3 events per year, which is quite alarming but still less significant. Considering the second scenario, that is relief valve release. After the protection analysis, the residual risk was found to be 3.534 exponent negative 4 events per year. Quite low, but considering the aggravated community risk, it amounted to 0.7 event per year, meaning at least one event is expected every 2 years. This is quite alarming. To better understand the level of damage we are expecting, consequence modeling was carried out. Three major effects were considered: toxicity, flammability, as well as overpressure effect. LPG was modeled as butane, and the extent of the levels of concern from the release point along the wind direction are presented here. For the toxicity effect, red zone implies the area within which the concentration of LPG is capable of causing severe head injury and even fatality, whereas the orange one is capable of causing severe head injury, the yellow zone breathing discomfort. When it comes to flammability, the red zone implies the area within which the concentration of LPG is at the lower explosive limit of LPG. Meaning any slight ignition can lead to fire. Since LPG is denser than air, once it is released to the environment, it tends to accumulate, forming a vapor cloud, since it cannot be easily dispersed by air. Therefore, any slight ignition can lead to fire and consequent explosion. The orange zone is at the 60% of the lower explosive limit, and the yellow zone at 10% of the lower explosive limit. So in case vapor cloud explosion occurs, the overpressure effect we are expecting in the red zone, even though it is not exceeded based on the model, since the case study plant used was only storing 22 metric tons of LPG, so the red zone was not exceeded. At 1 psi, there is expected damage of building structures, whereas the orange zone is at 0.7 psi, which is capable of shattering windows and damaging window frames. Then the yellow zone is capable of damaging shattering glasses. We can see that the effect extends up to 132 meters. That is the 10% of the lower explosive limit. Even though there is less possibility of fire at this rate, but because of flame buckets, formation of flame buckets, there is tendency of still fire and explosion. So, summing up all the results, we are able to understand that despite the regulators are trying their best to safeguard our LPG plant, there are still hazards which are capable of causing catastrophic incidents. The regulatory standards put forward by NMDPRA are adequate to safeguard plant risks. However, when we consider cumulative societal risks, there is room for improvement. Finally, even without direct fire and explosion, relief valve release is a serious case that can cause subsequent fire and explosion and even health effects to the communities. And the recommendations were put forward as such, and further research should be conducted using multiple case study plans in order to account for variability in the level of adoption of regulatory standards. Similarly, the further research should also consider the integrity level of the plan with respect to other incident scenarios. And stakeholders should review the findings of paper with the aim of better safeguarding the communities. Finally, a feasibility study should be conducted for containment layer in our LPG plants. Here are the selected references. I would like to especially thank the NMDPRA, the staff and management of Ahmadu Bello University, especially Chemical Engineering Department, the staff and management of LPG plant for their seamless access to data. I would also like to thank you for the opportunity to present this result to industry experts as well as stakeholders for necessary action to be conducted. Thank you very much. Questions, observations?
Wow. You know, you did not disappoint. When I saw this paper, I had a personal bias. I just said this must get to the finals, and you did not disappoint. I don't know why this people didn't get in Africa contest, you know, but
I think because of the small
yeah. Now, my addition to the paper is to probably see how you can also extend the categorization of the possible hazard. Because most of our LPG plants are within highly populated areas. So if you could also just show us some kind of map to show, oh, if this happens, these are likely impact zones. Beyond just that scenario, that will also bring it to light. So, you know, your paper also can also be used as a policy statement. They are for policymakers to actually pick up what you propose to enact very strong policies on how to set up these LPG filling stations. Please change that from plants to stations. We have very limited LPG plants in the country. We have a lot of LPG filling stations. Yeah, good job. Well done.
And luckily for you, NMDPR is here. I'm from NMDPR. So well done.
All right, John, please can we get it?
So please, can you furnish us with all this? Email them.
Yes, sir.
Please, I just have a few observations. You go to the methodology. One of the minuses you see the methodology, compare precedent. Honestly, it's too long, you don't need to make it shorter. But at least someone from France can physically see what is within the whole advantage.
We have to accuse BEJ for that.
Yeah.
The projector is not good enough. He has done his job.
It's not clear enough, but I think being the funds and you can see the plate number one, like I say, as of at least. You also have space.
It looks like you use pictures to is a picture. This is a picture of the business.
It's not a picture. You can increase the funds. You can increase the funds. You can increase the funds.
Maybe different pages.
So that you can
What's the one from the
nothing to do with this. I just look at that.
Okay, see, what is written on this green?
It is the layers of protection with their probability of
Yes.
Well, you can just quickly run them.
You can increase the contracts on the writing of the treaty to make it more clear. Also, please try to minimize the wording. Please, let them reflect on this. I want you to see the wording. The wordings are clear. It's hard to if you make it reflect on what they are, you understand what's
All right, well done. Thank you guys. You know, no wonder you were active for 15 minutes. All right, let's take Enoch. Enoch. Please, let's clap. It will help to visualize Enoch from Netherlands. Just a minute, just a minute. And I want to appeal, once the presentation is on, let's delete movement. Okay, so the presenter won't be strategy. So they are working with very little time. Okay? Jerry, are we ready? All right. That's a minute. A minute. good already? All right, end up. The time starts now. Good morning, ladies. Good morning, my name is Nicola from Fairness Technology. Presenting my data driven insights into the limits catalytic processes for emission reduction in low carbon refining. So the global refining industry faces major problem of balancing energy efficiency, reducing carbon emission, and also widening cost effectiveness. So this research just produced insights on three major basic classes of catalysts, catalysts, meta, and so the world is shifting into global shifting into energy systems. Hydrocarbons, we are using hydrocarbons, the world is shifting into world of more renewable energy. We cannot eradicate the world of hydrocarbons. We can still optimize it using catalysts. Because hydrocarbons not only for fuel, but also for other chemicals. So the role of hydrocarbons in this transition cannot be fully eradicated, and there is a need for using catalytic processes to reduce emissions. And my research, these are my research objectives. Firstly, is to look into catalytic performance or look at refining, and the first step is to focus on three basic catalysts, that are meta-based catalysts, meta-oxide catalysts, and zeta-based catalysts. And the key metric that I'm going to analyze are the TOF, that's the number of frequency, that's how fast catalysts perform in reactions, and selectivity, that's how they are for the process, and sales conversion, that's how fast and how much, how the percentage of how you convert CO2 and stability, that's the time that is spent. And the next is using a data-driven approach, that's using computational data from literature, and also data, using computational data from literature, and optimizing them using digital pipeline. So the next step is to identify optimal catalysts, balancing emission reduction efficiency, and the other one is to provide insights that develop sustainable refining technologies. So this is the methodology. I got 100 data for 100 catalysts for computational sources, that's open catalysts. And I went into computation with them using atomic simulation environment, and this is functional theory. And these are key performance metrics. That's number of frequency. Number of frequency shows how fast the catalyst works, and selectivity, how well it fits for the process, and safe conversion efficiency and stability. So that's the key findings that I've found from my research. From the data analysis part, that zeolites have high selectivity, durability, and they are ideal for long-term use. Zeolites have high selectivity, durability, and they are ideal for long-term use. But the thing about zeolites is that they are very durable, and they have high selectivity. But they cannot convert, they are not very high in CO2 conversion efficiency. But meta-based catalysts, they have high activity, but they don't last long. They start well, but after some weeks, they stop working, like, because the active cause that causes catalysts to work, they are being blocked. And for the this meta oxide, they have high CO2 conversion efficiency, and they are not very stable. When it passes, this is periodic. I use 300 degrees Celsius and 10 bar, but when it passes like 20 degrees Celsius, 50 degrees Celsius, it stops working. So the trade-offs between the turnover frequency, stability, and CO2 conversion efficiency, that what I derive from this is that none of them is perfect. None of these ones is perfect, because these are meta-based products. They have high activity, but they have lower stability. But the zeolite has high stability, but has lower conversion efficiency for CO2. But the zeolite, these meta-products have high CO2 conversion efficiency. When you have lower stability, and cannot last in high temperatures, because in the refinery-like condition, their tendency for temperature to always continue increasing. So it is the kind of meta-based oxide. So they tend to stop working after they are being exposed to a particular temperature. And this is visualizing the heat map derived from the data. So the TOF versus the temperature. This is the TOF here. This is the TOF versus the temperature. The TOF versus the temperature.
make there and this is number.
Just continue.
Okay, I want to point to some metrics because this year's versus temperature. So I'm going to okay, thank you. So this is the fuel versus the temperature. This is temperature giving us minus 0.4, and this is the negative correlation. It's a negative correlation factor, and it's on this blue. So this red is positive, but this blue is negative. So this minus 0.4 is giving us that it's closer to the and giving us the negative. It's giving us the negative correlation. So the thing is that when the temperature is higher, QF, that is how fast this catalyst will. It tends to decrease. When the temperature is higher, QF tends to decrease. This can you move up to this? I just move up to the other side. So this is CO2 conversion efficiency of stability. CO2 conversion efficiency of stability. So this is the CO2 conversion efficiency versus the stability. This is the stability of the CO2 conversion. That's giving us negative. This is a weak, this is strong, negative correlation. So that means when the CO2 conversion efficiency, is high, it's less stable. When the CO2 conversion efficiency is high, it's less stable. And the activation energy versus fuel temperature. So this is also giving us the negative correlation here. It's giving us the negative correlation. So that means when activation energy is high, the CO2 frequency, which is how fast the catalysts are going to react, it's not going to be very fast when the activation energy is high, the CO2 is slow. So balancing efficiency and durability. So from this basic metrics that I analyzed shows that none of them is perfect. But if the insight is that if you can balance, if you can find a way to balance how better have high activity.
I said it was only one person.
And feel like they have
Actually, I can see
they don't convert CO2 efficiency. Or metal oxide, they convert CO2 efficiency. They have high CO2 efficiency, but they are not stable. And when it's at a particular temperature, you tend to stop working. So this structure here is when zeolite now, zeolite is very stable and it takes a long time when it sees in catalyst, when it's combined with metal oxide have high activity. When it's combined, it tends to bring a kind of catalyst that are very stable and is going to increase. When zeolite material is used with metal, it tends to bring a combination of high activity and stability here. So the conclusion is that catalysts are the future of sustainable refining in the industry, and data-driven approaches can help to optimize catalyst performance. And the future researchers can focus on hybrid catalyst and process optimization. That's what I've said in the first place. If you can go through a catalyst that can have the stability of metal, that have the stability of zeolite and the CO2 conversion of metal oxide, and that can be as stable and that can be as fast as metal oxide. So you can have a better catalyst for low carbon refining. So I acknowledge to my side like and to all the people from my chapter directors, thank you, and to everyone that listens, thank you, and to my judges thank you very much.
Enoch, good job, well done. I like the fact that you are on progress, right? Really good. And thank you for this wonderful presentation. Doris, let's just take it on.
So the focus of the work is addressing low carbon challenge, right?
Low carbon refining. Low carbon refining.
So from this map you were showing, are you trying to show the performance? Is it that the higher the values you're having in those boxes, does it mean the performance are better? Yes.
This map has the discussion of these key metrics and also my data. The key metrics that I use for this process, photograph lens is how fast catalyst work, how fast the work in refining, how fast. So CO2 conversion efficiency is how catalyst convert efficiency using the amount of carbon dioxide.
Yes, so I know my question is, does this map, what you got from the data you use, the one that displayed this map, what is it telling you? What exactly are you interpreting from it?
I'm interpreting the insight from how this, if you have fuel frequency, that means when you have higher value of fuel, I mean, because we're getting negative correlation for this fuel evaporation. So that means when you have higher temperature, fuel intensity, that means it works when you higher temperature. Because at a particular temperature in the refinery, it tends to work in temperature, because the temperature in the refinery is always tends to increase. So at a particular temperature, the catalyst stop working. That's the
trade-off.
So for this CO2 conversion efficiency versus so when this one also works in negative correlation. That means when the CO2 conversion efficiency is high, that means it's suggesting that's our most that's for metal oxide, because metal oxide are the ones that tends to.
All right, any other question for you?
Yeah, I want to comment on the slides that with this one particular, warnings graphics, what is warnings of yes. One by left, please you have increased them. Okay, you have increased them. Go to the next slide. You see, all the warnings are small, there are a lot of spaces that you have left out. So your warnings should be large enough for the audience to see. You understand?
Let me see. What are the catalysts?
Meta-based, they are meta-based, they are good like meta-based, meta-oxide and fluoride.
Can you restructure that second bullet point as an objective? You just, is it evaluating key metrics or analyzing key metrics or yes, or showcasing key metrics? What do you intend to do?
Yeah, this data actually is coming from open catalysis. Open catalysis is website for catalysis. So these key metrics are what I got from it. So these key metrics are just data for some particular type of catalyst. So these catalysts are based, they are based on meta-based oxide. So meta-based oxide, we have other catalysts. Just the Google is meta-based.
An objective and not state that you take to achieve your campaign. So
this is just this one.
What's the difference?
These are what I think we evaluate the performance of meta-based oxide, use meta-oxide and do that. And the key metrics that I use are this one by the
So that this is not objective. And you want to present objectives. What are your objectives?
I will get into this.
Evaluate kinetic performance. Okay, step 1, performance and 3 catalyst types. Analyze. So step 1 is not objective. Step 1 is an objective.
Yes, sir.
Did your supervisor go through this? Did anybody check this slide before? So we have a standard. Your objective should be bullet points. For the graduates,
you can't have
2 or 3 objectives is enough, but what you put in there is completely not it.
try and move this, make it like at least try to also recognize it and it's much more quick.
Okay. All right. Thank you. Good job. Good job. All right. We have the privilege of having our Vice Chancellor in our midst. Please let us welcome him. So from time to time, we also expect you to make some comments.
Not the problem.
We just align us back to standard.
Not the problem at all.
All right. We'll take one of the PhD students' presentation so that they can draw them in. And Mr. Bob, you can have a presentation. The title of your presentation is just pick it up. Thank you very much. All right, let's give it. Judges, please, let's get at this. You have 15 minutes, so we expect you to cover up your presentation within that time to enable us to ask questions. All right, your time starts now.
Thank you very much. Good morning, ladies and gentlemen. Or I'm going to stand on your assistant. My name is Bobby, and this is my work. Oh, thank you. Thank you very much. I'm fine. Thank you very much, sir. I'm enjoying that. Thank you very much. My name is Bobby, and I'm working on computer-aided analysis of dimensionless pressures and derivative signature of a vertical wave completed with a pair of inclined constant pressure boundaries. Constant pressure boundaries, these are reservoir external boundaries that support the reservoir from an external source as is being produced. There is support from the external boundary, which can be from either paper or gas car. Basically, an understanding of reservoir boundary is very important for oil field development and management. Apart from that, we also have other boundaries, sealed boundaries or mixed boundaries and this. And now the dimensionless pressures actually used to simplify reservoir engineering and well testing calculations. Okay, we can simplify it. They actually ratios of accelerated pressure to actual pressure. So in other words, we can start working with dimensional pressure, simplify the calculations, and then we convert back to actual. Dimensional pressures have been used several days for a lot of work. It can be used for identifying the flow regimes and a whole lot of work as far as reservoir engineering and wet testing is concerned. A lot of work has actually been done using reservoir, using dimensional pressures and their derivatives. Okay, I've looked at a lot of some of this work, and okay, we are going to talk about we are actually focusing on this project on where we are completed within inclined boundaries, inclined angle. Okay, and in that regard, a lot of authors have done work in that line. I must commend them because without this job, the whole work was a little bit tough and challenging. But however, they have limited their work to convenient angles, focusing on angles that were a little bit easier for their calculation. To bring this thing down for us to understand is that when the well is completed within fault boundaries, the boundary acts as mirrors, okay, acts as mirror just like in physics, all right? And so the object well hits the boundary, produces an image well, that produces another image well, produces another image well, and like that, which is dependent on the angle of inclination, okay? So as you go on, we see so a lot of these authors did work, but I noticed that they only kept safe calculation, maybe 90 degrees or thereabouts. Okay, and why? Because most calculations in reservoir engineering, especially in wet testing, as regards this kind of modeling, very, very tedious, very rigorous, and normally prone to error. So I can understand how safe. A lot of I didn't show because of the time. There are a lot of mathematics I will not be able to show here. Okay, but however, the model. What I did in this job is to design a computer program to help calculate these image well distances, and irrespective of the angle. The program, the papers, we see 90 degrees, 60 degrees, and the 102 and that stuff. But this software, irrespective of the angle, as little as 10 degrees, it can tell you the number of images that object well, that is drilled, can generate, and it can also tell me the well and image distance in all, which will definitely now help to analyze my dimensional pressure and dimensional pressure derivatives, and which will give me the results I need for perfect judgment in my well field development and management. All right. So the models, the mathematical models I use in this design can be already established models in petroleum engineering and mathematics. Okay, so these are just, they were converted for equation 1, that tells us the pressure drop in the normal dimension form. Okay, equation 2, that gives me the dimensional pressure drop P. Okay, and then the dimensional pressure differentials, dimensional pressure derivative, equation 3. So these are the basic equations that forms the design of the application. In equation 4, you see that if you say theta is the angle of inclination of the boundaries, like I said, we can have a seal boundary, constant pressure boundaries, this boundary, but in this case, we're looking at constant pressure boundary. So the angle, if the sealing boundary is 90 degrees, so we're having pressure to about 90, So that will be 4 and so on. That tells me that the number of images that will be produced by that, in that case, will be 4. Okay, so that's the computer recognizes that, and it's able to generate the terminator's pressures and the terminator's pressures derivative based on that information that is given. Okay, that is where the limits from other literatures that they have to in convenient areas of language. All right. Now, the one more principle that I need to highlight here is the principle of superposition. Because now we're talking about an object well, computed within ceiling ports, and like physics, images are being generated because of the boundaries, producing other image wells, which are also impacting total pressures. The insurance pressures also impacting the image wells. Pressures now are also impacting on the object well. And so that's where the principle of superposition comes in, which tells me that the resultant pressure drop is a combination effect of all those other image wells and the object well. So I employ, in addition to those equations I earlier presented, I also employ the principle of superposition theory. So that is it there. So you can see the first one, the object well, the second, the image well, just like that. So the number of image well will determine, go to n. All right. So the number of image well will tell us the number of how long the equation is. Let us move. Okay. This is locally. This is our software. It's for us. It has been developed here, supporting local government, the federal government's local content drive. All right, and leveraged on the existing and the already established principles to do this. All right. Now, basically, what we have done, right? I've looked at all those other papers and I've made a comparison of the results, and it's perfect. Okay, so right there at the right hand side, I just infused the parameters that's available. All the parameters that's available, I infused CDs and the rest, and then I infused my n, which is the I beg your pardon, the theta rather. Sorry. I include the theta, okay, which tells me the angle of inclination. And once I say calculate, it generates this. It is just so good. As a matter of fact, I was already it generates this, okay, irrespective of the angle that you are looking at. In all the literatures that I've seen, I've never seen so in this annotation anyway, let me not say that. Let me not say that. I have Leonard superiors here. Okay, thank you very much, sir. So this is the contribution, all right. So this is that this generates the terminator pressures and the terminator's pressure derivatives. It tells me the number of images that have been formed from the data that is being imputed into it, and beautifully, it calculates all the image distances, or it automates and calculates within, split seconds at a click of a button. In fact, as a matter of fact, I understand from when I look at the work that how rigorous it can be when I'm computing manually these dimensionless pressures. Is very trouble. It can be worrisome. It can be worrisome. As a matter of fact, I was review one work. I must commend all those authors, because without them, I would have gone this far. I would have not been stopped and everything would not be done. But when I saw their work, it gave me light, and I was able to come this far. A particular one there was even a small. I had to call the author. So that is just it, and it generates these images, generates this, tells me the number of images, calculates all the distances, and generates, most importantly, which is this paper, generates the dimensionless pressures for the time, the dimensionless time, or the dimensional time that I'm choosing, and then the dimensionless pressure derivatives, calculates the slope, and all. In addition, the subject can do so many other things which actually is outside this paper, pressure builder, line boundaries, single wells, multiple wells, superposition, vertical wells, horizontal wells, and it's our own. And what I did was to compare the leverage on the software to do calculations of various angles of inclinations of these boundaries, okay, and make a comparison and came up with this. Beautifully, I see clearly that the angle of the number of images will be inversely proportional to your angle of inclination. As a matter of fact, it tells me that, it advises me that when locating my wells, locate it as far as possible from the boundary. Okay, if you locate from as far as possible from the boundary, it will help me to produce longer, clean oil. All right. Okay. So, and you can see the derivative graph there, the blue one down. From literature, that proves to me that this boundary, the software really helps us now to identify our boundaries. So as a reservoir engineer or in the industry, you have to have understanding of the type of boundary that you are developing. Okay, that's going to help you in all of it. From this local software now, I can see that this boundary is a constant pressure boundary from literature. Constant pressure and which is beautiful. If, in other words, if the blue line has gone the other way, it will tell me that this is a ceiling boundary. So all this information helps the engineer in proper oil field development and management, which is very key for the success of that. There are so many other results that we can get from this. So it confirmed that pressure gradients are also a long flow, predicted by the equation. Most importantly, the application was actually developed using so many user-friendly graphic user interface. So in other words, it's user-friendly. You don't need rocket science to use the application. Input parameters, click, and it generates result. Let me not bother you too much and talk. At least I want to say a big thank you to the panel for having the opportunity to come this way to make this.
Thank you also for sparing us. Maybe I saw at the wedding, my thinking was that you were going to kill us with mathematics.
I didn't put everything.
Thank you for not putting everything. Because I remember when we were forced to do the dimensionless derivative for some of the things we're talking about. It was blazing mathematics. We spent the entire day doing mathematics. But thanks. Good job. Yeah. It's good that you also upscaled your work into proper software design. Yeah. And that also helps a lot of engineers in getting their work done. Locating your boundary conditions is very, very critical in reservoir engineering. And that will also help a lot of reservoir engineers to properly land their well. Sometimes if you land your well, you are supposed to target it already, you just go and see yourself in those states. Thank you so much for the work. And God bless you. Judges, let's take comments and questions.
I think it's always research. It's always research. The software, if you mention the name of the software and you keep on community and local.
It's by design. That's why
It doesn't have any.
for now, I just only work test pro. I'm still on my supervisor, but I'm gives me analyzing that. And I decided I wish to make it available because I found that even in my school, there are no regular software to use. I understand they're very expensive, license is expensive. So this one, I would like to make it available, not just for London, for every other school, so that young people can make use of it.
And this patent is very, very important. Okay.
So in a nutshell now, what is new?
What is new? In a nutshell now, it's a little addition to already softwares in the industry, but particularly this one that helps, in generating number of images automatically, and most importantly, calculating the image distances that has been generated, all right? All of them. In the paper that I've reviewed, these image distances have been calculated manually using trigonometry ratios, Pythagoras theorem, which I didn't want to show here, because we need to use trigonometries and protractor to be drawing and getting images, and so you can use sine rule, cosine rule, Pythagoras, and so I saw that, and that was why they limited themselves to just 90 degrees and maybe 120 degrees, the one that they can easily do. By the time you shift this thing out to like 7 degrees, everybody will wrong, and things like that. So, but with this application, no matter the degree of angle of inclination, you just tell it, and it generates the polygon, tell you the number of images, calculate all the image distances.
Let me ask you a quick one. I'm more interested in the reliability of the software. Most of these things are just garbage in, garbage out. But at the same time, we said it is friendly, user friendly, and the user just needs to plug in their values for the new parameter and get their estimated results. But let me ask, because normally PD or dimensionless pressure is being called is dependent on parameters like durability, the height of the reservoir, the total compressibility, and even the skin phase, right? So I don't know. You guys have done all the dirty work on the back end. But did we consider
This question is
did we consider why you're doing this? I mean, it's computer did we what
let me calm down because this question.
No, it's not. Don't worry.
Thanks.
So why developing this software from first principle? I mean, we know PG equation just like you said. Yes. They are very rigorous.
Yes.
And what were the first principles, that you deployed, before you get to this stage? Like I said, as far as I'm concerned, I am more concerned about the reliability, the confidence that will come out from the output of this software.
Thank you very much, sir. For reliability, I think we can just be rest assured 100%. Why? Because what they taught us, already established features, already established formulas. These are the engine room. These are already established. We start from the line source equation. We are starting from the line source equation. So what I've done is not new, as in I'm not bringing something from space. I'm leveraging on these already established equations. These are the background. This is the engine of the.
Is it modified with any of this equation? Or otherwise, you can just repeat this parameter with Excel and you get the result.
Not for image distance. Not for image distance, I can show you that.
You need to.
Not for image distance. This is a little bit more advanced one.
So that is why I'm asking if you modify.
No, these are already established.
There are some things you didn't show here. Yes, that's what I was saying.
Yes, that's yes. For example, we are going anti-clockwise to generate the image map. So those are things that we wrapped up and we leverage on superposition theory. This way we are coming out. So that was just the beginning, and then we have to build up build up to 7. The main engine here is 6 and 7. So when you have that N, that accounts for, that is where, so the job is being done by the application. Alright? Mine is to give it that, say, this is what I want. So when you give me a number of N, it generates the D's. It generates the D's. It generates the D's and gives you. So why it's safe is that the equations, the theory that we have leveraged or we have used are the established and accepted theory. And we've tested this with the papers, with those authors' papers. Perfect. Perfect. I didn't want to mention that he had to correct one. And when I called him, he acknowledged it because he was involved. Software cannot lie, so it was perfect.
First of all, the main purpose of this work is that the mirror image, right? It's a mirror image. So just for the sake of the person of work, why do you use or what are the credits, what are you using for mirror image?
The what does that is that because of the faults. The faults. It's the faults. Alright? Like I told you, there are different types of faults. We have a seal fault, sealing fault. You can impermeable barrier, impermeable barrier, no flow. Alright, seal flow. Okay. So we can have constant pressure fault, which we are talking about, or even mixed fault. Alright. The presence of that fault, alright, is what is creating that mirror image, that is creating that mirror effect, right? In real time down in the reservoir, which we are not seeing. Okay? What we are saying is that for you to get your dimensions, your pressure, okay, in the object well, alright? There are imaginary image wells which you are not seeing that have been created by that fault. Alright? And so you must take account of their contributions in this pressure distribution. In this diverse project, you must take account of their own contributions. You know, that is where the image, the need to understand the image. So
and their distance.
And their distance.
Two things I wanted to get. Boundary protection and distance of where to boundary and where to boundary. So yes, let me use the words of your survival. I did not see the professional your equation 6 and 7, I think you're going up to infinity number of angle too. I think see the professional error. I know the more you are doing, the more errors will be getting like.
So what happens in the errors?
Yes.
See, first of all, I'm talking about degrees 0 to 360. But most importantly, even in this, okay, in this design, you don't have a protractor. Alright? So your main concern, our main concern, my main concern is design, or rather, is now from like 0 to 1/8. Okay, the other one is so if you turn it, you have to get it's like a similar thing. I don't know if I can. You understand?
It's like
so,
you go
the your protractor now, you don't need to have a protractor of 0 to 360. You just have 0 to 180. So when you switch it the other way, you still get the same thing. Alright? The beautiful thing is that this the equations are plugged in.
Oh, guys, we are not discouraging you from doing reservoir engineering. All right, thank you. Thank you.
I think we can let it go.
Based on this topic, we have had a lot of modes. More than 20.
So can we just go back and just be one with orientation?
All right.
Just be one with orientation.
All right.
It's a nice work. In fact, let me just tell you now. Because of this topic, I almost just disqualified the paper. What saved me was when I saw Adewale. Anything that concerns Adewale must be good. He will not allow you to come out if you don't do wrong. And you did not advise disappointment. Just be wrong with us.
Sir, you said you are finished, yeah?
Okay, this is just these are just the program, the software we make, which is right there.
What
It's in
for your slides presentation is just starting where you presented the slides. And also for all slides are going to go to the picture. You see, go to the introduction. And this introduction, you have those bullet points.
There's 2 words. I think we said it.
Honestly, go to the issue. Look at the issue. It's not properly presented. It's not how the issue is presented. It's how the research gap.
So what?
I can't see any research gap here shown. Limitations, no outcome.
Just take note of that. All right, thank you. Please, the round of applause. All right, let's just take the second stage with Abdul Rahman. Have you tried? Have you tested? Is it okay? Judges, are we ready?
1 minute. Okay, I'm ready.
Just a second. Okay, you ready? Are we ready? Abdul Rahman, you have the floor.
My fellow students, my name is Dr. Rahman Aswati, and I will present the topic paper entitled Enhanced Recovery of Residual Oil from Nigerian Samples that were using paper the introduction. They have been pushed to move from the normal fossil oil to renewable was the fact remains that petroleum is the largest production of energy, and as the world population increases, there is need for the amount of energy to be increased, and that is what is called the enhanced oil recovery. The oil recovery, we have oil processing, we have the primary recovery involves the use of natural gas. We have the secondary recovery, which involves realizing the rock formation using water primed for immiscible gas. And any other method employed aside from is called enhanced oil recovery. The techniques that are used in enhanced oil recovery, we have the thermal recovery, gas injection, chemical recovery, and we have the microbial. There are challenges with the thermal recovery, gas injection, and chemical. So, and now the gas gas enhanced by recovery are now in the flow. So, and the examples of the chemicals that I use include acid, alkaline, salt, surfactant, polymer, and the combination of the alkaline, polymer, and the rest. What is this defective solvent? Then, among the chemicals, we have what is called the ionic fluid and ionic fluid is. This defective solvent is an example of ionic fluid. It is formed when we have two salts. When two salts are mixed together in a particular ratio, and to form a defective point, to form a liquid, and the liquid must be having a melting point lower than the individual component. And this typical example we have A here is the melting point and B here with the melting point. After they are mixed together, after the point is formed, then the defective form is defective solvent is formed. This example, typical example of defective solvent. Why defective solvents? They are easy to prepare, they are environmentally friendly, they are neither volatile nor flammable, they are less toxic, biodegradable, and they don't react with water. But the most important thing is the tunable property of the defective solvents. They can be tailored to a particular application depending on what you want to use it for. And the problem statement, before giving the problem statement, of course, the literature review has been done due to the restriction in the number of slides, and so that's what we're going to provide. In 2014, an SME program like this, the application of defective solvent was introduced in the international world, and from there people have been working on defective solvent. And mostly the defective solvent that was used is choline-based defective solvent. And it has been performed an experiment to see how the defective solvent interacts with the asphaltene, and it found that the defective solvent only interacts with the aliphatic aspect of the soil of the crude oil. That is, it can only react with the choline chloride defective solvent was found not to reduce the IFT of the heavy crude oil, and detailed interaction of the gas and the oil as well as the mechanism is also limited. Here is the aim and the objectives of the work to carry out experimental and computational study on the use of tetrabutyle ammonium bromide and different methods using tetrabutyle ammonium bromide as our salt, the dimethyl sulfide and dimethyl formamide as the hydrogen delta for samples, and investigate the life and the test was carried out on the IFT reduction and off flooding test. Then we have the computational aspect. In the computational aspect, it has been found that in most of the literature, they look at the dynamic simulation, the molecular dynamic simulation, whereas in this work, we look at the quantum mechanics calculation to look at the interaction to develop what is called molecular descriptor that can qualitatively give that can say something about the property of the chemical, whether the chemical can be used as chemical agent for enhanced oil recovery. Here is the result. We have the physical properties like the viscosity, density, the surface tension, the moisture content. The basic properties of the ESR that are presented here, like in the ammonium bromide and salt oxide, it was found that the defective solvent, the IFT was reduced up to 87% of the heavy oil interface for the DS1 and 83% of the DS2. That is from the 6.5 millinewton per liter to 0.89 milliliter per liter for the DS. Using synthetic rye, while the other one was carried out at reservoir condition. In this case, the reservoir condition means that the crude oil was the flooding was carried out with the formation water that came with the crude oil, and the temperature of that particular crude oil, which we were told it was 80 degrees Celsius, and the pressure of that particular reservoir, which was 4,000 psi, was also used. So at reservoir temperature, we have the at ambient temperature, we have incremental oil recovery of 17.0% for DESA and 15% of the original oil for DSB. Then the next thing was the recovery factor, the recovery factor at reservoir condition, which was carried out at Desert Engineering in Port Harcourt, and this one, total displacement was seen. And in this one, it couldn't be presented as the previous one because we have emulsion when it was coming out. So we have allowed it to settle, and after it's settled, that's when we obtain the secondary recovery and the primary. Then we have the water chaser, which we use to calculate the displacement efficiency. The displacement efficiency was also obtained, like this one, we have almost 70, and the other one, we have 74% displacement efficiency. Then after the experimental thing, we try to look at the computational aspects. And the computational aspects, the major factors, we have the rock sample, we have the oil, water, and the chemical we use. So we need to look at the interaction between these particular factors. How do they interact? So that quantitatively, because in most of the literature, they use the black eclipse to look at the amount of the oil, that's the quantitative amount of the oil that can be recovered. But in this case, we are looking at the effectiveness or efficacy of the chemical to be used as chemical agent. And this one carries out the method optimization of this particular components, the oil, the rock, the brine, and the using pattern 20. Then the interaction, this is the interaction. The binding energy was calculated using molecular mechanisms and PMF. It was in one of the papers that we found that the initio, the PFT, PMF, all of them, if they are used, they will have similar trend. It has been established. And because of the fact, the number of atoms that are used here, we cannot apply the DFT. It is computationally expensive, and we don't have that supercomputer that can handle that. So the MMF and EMF. So the interaction is that when you have negative, the stronger the interaction. Like here, we have the brine. This is brine. We have minus 0.55 here, and for ES, A and oil here we have the minus 0.68. It shows that this one is the interaction between our chemical is stronger than that of the brine. We all know that they use brine for secondary recovery. So now what this one means is that this one can reduce IFP than the brine, because the interaction here is seen to be stronger. So the same thing with the interaction for the sandstone. For sandstone, two things are involved: the absorption as well as the wettability alteration. So if you have the interaction between these, the stronger the interaction, we can say that can be used to alter the wettability of that rock. And the next thing is to determine the mechanism in which the chemical is using for the recovery of the oil. Then we have the D1, that's the molecular descriptor one, is showing the ease of emulsification. The second one is showing the wettability alteration and absorption. The third one is showing the displacement or sweep efficiency. And the final one, the fourth one, is showing IFP reduction. Now, to make sure that all of them have even distribution, it was normalized. And after normalization, we have that IFT reduction is the predominant mechanism for this for the DS1 to recover oil. And finally, in conclusion, we have ESA was successfully formed using the ratio of 1 to 6 and the viscosity for DES, the higher the viscosity, the stronger the hydrogen bond interaction. And for the IFT, the IFT was reduced to 0.89, and an ambient temperature we have of 3.14 degrees percent, and we have 15.00% for the ESA. And at reservoir condition, we have a displacement efficiency of 70.31, 74.37 were also obtained, and the binding energy also indicates that the ESA uses IFT reduction, while the SD uses wettability observation and IFT recovery to recover oil. And acknowledgement, we have the team. We have a team from Covenant University, Alpha Babalola, University of Utah, and ABU. And we have acknowledgement. Thank you for listening.
Thank you, everyone. All right, good job. Well presented. I'm sure there will be questions for you. Share it. Okay.
Okay, mine is the both question and of course suggestion of what to do. Yeah, please look to that page. I think second or fourth people I don't see you are there. Okay, yes. So if the error, there's one you are missing out. Gas injection is they classify it as primary. Because we inject produced gas or dry water. Okay, by injecting the second recovery, we are injecting what is already existing in the reservoir, nothing new. Okay, the tertiary recovery, we are injecting what is absolutely new to the reservoir, foreign materials. Okay, so gas injection is now second recovery. Why? Miscible or immiscible by CO2. CO2 could be miscible, it could also be missing. That's now the tertiary recovery. Okay. Then compatibility, yes, you mentioned it essentially. You always work with what's called and the oil and water stuff. How compatible is it with the reservoir with the oil itself? Or you did something on it. I don't know if, but from what you said, it didn't come out particularly like you say the chemical is compatible with oil or without oil and you.
Yes, exactly.
Well, like I said, I'm getting something totally new, foreign material. Yes, from all these things now, these are technical.
Okay.
I have my question is that, is it compatible? Because if it's not compatible, it will affect the reservoir and the oil, it will react to the oil, it will react to the transport. And my damage porosity affect the ability.
We actually carried out information damage for the information damage was carried out to see whether it affects the permeability of the rock, losing permeability difference after flooding and before flooding. But we did that, but it's not included in this.
So what did the result come out?
The result is that the second one, that is the S1 yes, A has little effects on sandstone.
Of the ability of
the permeability of the
grade or regulation.
It reduces the permeability.
All of the other one.
So there was the
production of A was minimal.
Those are things that show. At least let's know anybody that will use this thing and know okay. So I mean, like you said, it's skin effect. You need to damage the least to it.
And they did not react to the oil. They also carried out IF2 reduction and FTIR reduction to see before flooding with the oil and after flooding, whether we can see another peak to show that there is interaction between the oil and the chemical.
So somewhere it's compatible with oil.
Very
or not compatible with sandstone.
Yes.
Then IFT versatility, we came to that at the point.
Yes, sir.
You know, for water wet reservoir, you don't need IFT, you don't need what we call it, you don't need an IFT material for incremental recovery. For water wet reservoir, potability simply shows the affinity of the fluid to glue to the rock. And most Nigerian reservoirs are water wet. So if Nigerian reservoirs are water wet, which means water is more fluid to the rock, oil has a tendency to flow or move. So well, can we now use this one? I don't know if you understand it. Let me come again. Most Nigerian reservoirs are water wet, right? Because IFT or waterability tells you the affinity of the fluid to take glue to the rock, making it difficult to be mobilized, to move. So when you have your water wet reservoir, you predominantly have a 99 will this thing be application?
Yes.
Is it chemical water based or oil based or your chemical? Is it water based or oil based or brine based? What did you use? The composition of your chemical.
The composition
yes.
is water based.
So that's why it's asking that question.
Yes.
If it is water based and your reservoir is water wet. How without applicable in Nigeria data that is majorly what but you are designing it for another reservoir outside Nigeria.
Yes, and majorly like what we do in India is the Nigerian did not started per se. So most of these researches are most of our the literature considered international because
so your work is an export, you're exporting your work.
No, sir. What we apart from the experimental, we're saying that if so we have any industry that want to instead of embarking on this very expensive experimentals and looking at aside the quantitative experiments that we used to use using Eclipse, we can also do qualitative analysis to see the efficiency of the chemical. I don't know whether we can. So the qualitative analysis is to see when you look at the interactions between the majorly the sandstone, whether dolomite, whether sandstone, or any of the lithology, the composition of the sandstone, the interaction, and as well as that of the oil. When it interacts with the oil, you can see that this can reduce IF2. When it interacts with the sandstone, you can see that this can alter retrograde.
So, okay, you mentioned something on dynamic simulation and quantum.
Yes, yeah, I said most of they use dynamic simulation, molecular dynamic simulation. That's the.
We did do simulation.
And we did simulation.
You didn't show those results now.
Sir,
or you didn't just present the result of the simulation?
This conference will be only presented another aspect.
Yeah, right. Then another suggestion, you mentioned something on the supercomputer, right?
Yes. The atoms, the number of atoms involved.
I would recommend, National Airspace Research and Development Agency in Abuja. Yes, they have a high performance computer. Okay. If you have access to them, you can use it.
But the software we're using is offloading machine, and that one, the temperature can also not be right. We cannot carry it out. Then we now went to lesser engineering for that.
So what about
the is still offloading machine.
Fine. Those are things which are the methodology.
Your equipment is
Sorry, sir, it's the coordinator that's.
Yes,
He gave us no, 10 maximum of 10 slides. The first slide should be introduction, the last slide should be profile, and the second one should be actual. So we are going to show the 3 slides.
The conclusion page, you know what is about the EOR? The main target is what they call recovery factor or recovery efficiency. In your conclusion page, you mentioned the recovery factor or efficiency.
Yes.
What you mentioned was displacement efficiency.
This is the recovery. That's the incremental recovery.
Incremental recovery.
Yes. And this one, the initial value.
That the incremental recovery is it after primary and secondary?
Yes, that's why it is incremental. After secondary, that is the answer.
Those are things they want to know. After primary and secondary, what more? Many percent more can I recover? That's what everybody wants to apply to the scholarship. Thank you very much.
You're welcome. Thank you. Any other comments?
I wanted to find out what is informed the choice of this law and the sovereign.
Yes, yes.
And the economics. Do you consider the economics? Do you consider the economic implication of?
Yes, we was at the early part of any experimental work. The economic analysis is not always considered. It's when the effectiveness of the chemical has been established. That's when they start thinking of how to optimize or how to reduce the economic analysis. Of course, the economic analysis was done for choline chloride based solvent. For our own several development, as for now,
we should consider it suggest an extensive project to the economy. Of course, don't buy and throw it out because it's Please consider it because if what is that or any benefits so are less expensive, then nobody will afford to.
The PhD work, right? So you need to do that.
Also, if you are able to compare your results, comparison.
Yeah, no base case.
This one,
No base case.
this one, there's restriction on the slide. Also, there's a space like in a number of hotels, there are also implication of the restriction. I presented this so many questions. Because of that, there are various spoken and there's few characterization.
We did characterization, we did the electrical conductivity, normal conductivity,
So two things to take away from here is do the comparison, establish the baseline studies, yeah, and then do the economic research. Your work is perfect. Good job.
These are all my work.
But we it's still going on because now we are trying to get a single molecular descriptor, just like a model that can be used for any of the chemical, whether polymer, surfactant, nanoparticles. Yes, this one.
You've done your standard defense.
Yes, that's just few.
All right, thank you. Please, a round of applause for me. All right. Why you doing that? The next will be account. The account will be
Coordinator, I have a suggestion. Can we take a quick break?
Yes.
So that our brain can be reformatted, because we will not be this one after taking 2 PhD students and now taking.
All right.
Let's take a quick stretch, 5 minutes, and come back.
All right, please come. Let's have the right challenge. I just
So we'll not be here today.
just just a minute, let's have it on record. Good morning, everyone. Good morning, festival. My name is Francis Muchi. So I just want to thank you so much for participating. Thank you so much. Thank you. I really appreciate just having a few comments I would say about this. One of the things I'd like to say is that for me, personally, this is the meat of the conference. This is the meat of the conference. I know a lot of times in SPE, you get carried away by a lot of things. But personally for me, I'm very particular about the technical, I still believe it's the meat. I'm still, let's see, what I'm trying to say is that personally, I aspire to ensure that our technical papers and technical sessions drive people to the ends and no stripes. I also encourage you to continue the way you're going. It's very important. The few other things of the safety for get us crossing so then we'll look at that and so we can do about that. You know that what it says feedback is a gift. That's what we say in the company. Feedback is a gift. So what I want you to take from here, fellow students, when you see the judges and leadership was giving you feedback, it's a gift. You know, like we talk about maybe like Christmas, the parties, a lot of people come bring gifts, you're happy. You don't refuse a gift, do you? You don't. If somebody says a lot now, you will gladly collect the alert and smile. That's the same way feedback, it's a gift. If somebody gives a feedback, like me, I can, in stomach, I get feedback, I get angry, why is that advising me? But one thing I do a lot, I go back and write and I think through it, then I improve my way. So to take that very important feedback is a gift. Always use it. Always take feedback and take it as something to improve yourself. I'll also say that maybe because of the industry and how we do two areas I want to talk about is that your presentation, let it be clear. Mr. Abdurrahman really likes your presentation. It might not be perfect, might not have it, but it's clear. You understand where you're going to, what it's all about, why you are going to do. I have when I came yesterday, because they told me I wanted to stay here, and one of the somebody gave up with me yesterday about using sawdust for cementing, spacers, and as an English person, I'll tell you, I talked about mahogany wood. Mahogany wood for me is very expensive. So you're trying to save costs, but then you're going back to mahogany wood. Right, and you're saving costs.
I read that.
Exactly, beautiful. So one of those things are things that, and then you first of all start with the fact that you want to, the fact you are doing is savings in comparison. That's what I'm asking you. The previous enhanced oil recovery methods, the other chemicals they use for the versus this your own. What's the difference? And I'm not really seeing it like that. So as an industry person, I'm thinking, so if Schlumberger or one other company gives me their chemicals, why am I going for this chemical? But I really like the answer you gave that. I said that when you do something, the cost is not really yet, and then that helps. Even as much as I wanted, when you put about the 17%, I wanted to see 17%, what were the other chemicals have they done? Is it 14%? So when you say it's doing 17% versus 12% or 10% from the other chemicals, then you see that light bulbs begin to go off. So that is, always think about the operationalization. We think about it. The question they ask me often, what are you doing differently? It's a very standard question. So what are you doing differently? And that doesn't mean
Because I see sometimes here people want to try and bring up something that is abstract, is just so they can get something new. No, it's not really, I don't think it's that my problem. My problem is that this was what was done before. This was their perspective. And I'm looking at it from just a different perspective. It's basically the same thing but a different perspective. And that's really all. Because when you take it to some kind of extreme, you find out you now begin to make it a bit too academic. And it's not realistic. I don't want to mention it, but you know that profit. He's a very big man involved in government right now. He has rockets going to space. But his car business has never made profit. That's what I hear. I think that's what is true. Maybe one last year or something. People are making money from the share price, but the car itself is not really profitable. And that's why you find it's hard for it to still make its way into, and you have the likes of the Honda, Toyota that are still making the biggest profits for it. Maybe because I'm old school in SP. SP is a platform to that. You're not to market it to market a company. You're to demonstrate the technology. Yes, people will come up and ask you later about you. Like after you finish your presentation, people will meet you and say, oh, what is, we do it a lot, oh, what my company would like to use that, what's the end they engage. But it's for SP itself, it's not a place to market into technology. It's not. Maybe it's changed now, maybe I'm not, but that's the way we operate. And so maybe two last things I'll say. The first one is, how many engineers here are from this school? Yeah. Anybody engineer from this school? We have them. They will challenge you differently. So I'm doing that one, I'm doing this one. Inspiration to make you think. Are there more things you can do? That's it. And the last thing I'll say in the presentation, what I like to share in my office a lot, I call it a problem triangle. You have a problem, you have a technology, the last is creating value. You must always have it. So if you have a problem, you have a technology, it doesn't create value. If you have a problem, you can create value from it, there's money to be made, there's no technology. You have the technology, you can create value, there's no problem. It sounds strange, but you have a technology that can remove, that can stop sand production in the well. Of course, you will make money, but that company has no sand production program. Think things like that. Technology, solution, creating value. So, again, I want to be appreciated for, like I said, it's the meat. I really love this part. Maybe I'll be blunt with you. When I was in school, I wasn't too much of a geek. I wasn't the top class. Later on in class, I started doing very well, but I was never the. So after coming out from the industry, I really appreciate it. There's nothing better than taking that technology we have here, calculating your choke changes, your production rates, doing your prosper model, that prosper now, but you calculate your increase in choke. And you see that when the well comes up, the production is there. It's I can't tell you how much that feeling is in our industry when you get there. It's beautiful. You come and you say you put acid into a well to clean the formation. And for me to calculate it based on that, you know that the pressure product will drop by about 30 psi, 40 psi, calculate and pressure top. And when you do it, truly it comes there, maybe plus or minus 50 barrels of oil. It's amazing. It's amazing. That's why I mean that the practicality of it is beautiful. So I want to encourage you. It's a beautiful industry. SP is beautiful. It's something that you'll enjoy once you see your technology.
Wow, thank you, Vice Chancellor Chair. Now you have given us an idea of what is board is going to look like. So more papers. And it's good, this year we have 96 entries. We were limited, initially when they talked about flying everyone, after we wanted 34 presenters, and later the court was paid to see that that number was cut down to 34. So I want to see more of those numbers next year.
Yes.
Yeah? I'm pretty very passionate about paper.
One thing I will say about it, and I think it was one of the that left asking me here, he said that, so, I don't think I've said that like the last 2 years, but he said that, so, PhD students present here. I said they were presenting. The reason why I know this happened before is that when you have the masters and PhD, you only have to put one person or two or bringing papers, so never really was a big deal. So I'm really impressed that you have PhD people, you have masters here. For me, it's very impressive. But before you dealt with a lot of undergraduates, and then you hardly have those papers. I'm really impressed.
And you also agree with that the papers here we've seen so far were a lot even better than what we saw yesterday. I know it was complained bitterly yesterday. Yeah. So we can do better as we move forward.
Exactly, that was good before.
Paper presentation, students need to be here. Because that is where the learning is.
Yes, that's what I'm saying, because there should be a way that we'll have a session where they're doing nothing else except taking papers so that you will come down here. So what I'm thinking of right now, which is maybe one of the harsh ways, that you get your snacks, your tea, everything here. Everybody will come down. Second session is the only one that will have that. Something that will bring people down there. Everybody will have it. So you decide whether you want to be there where there's nothing. You want to be here where the action is. So that's.
All right, thank you so much. So we just take 2 minutes. 2 minutes to just stretch your leg. Don't go far. Just stretch your leg. You need to take a call. You need to send a message. You know, just don't go far. Just 2 minutes, please. 2 minutes.
This my guy.